We are taught to look up for the future, to believe that our digital lives, the billions of dollars and trillions of messages, float in a pristine wireless cloud of orbital arrays. It is a beautiful, futuristic, and fundamentally incorrect illusion. Satellites handle just 0.37% of international data. For those keeping track of the math, that makes outer space functionally irrelevant. Over 99% of the global internet actually runs through garden hose sized tubes sitting in the freezing mud at the bottom of the ocean. $10 trillion in daily automated finance, classified military commands, and your personal data, all resting on a fragile thread of glass. There are 1.5 kilometers of fiber optic cable spanning the seafloor, enough to wrap the Earth 38 times. This is a hyper-capitalist nervous system, an underwater oligopoly connecting 1900 landing stations across the abyss. But this backbone is aging, and the world is running out of highly specialized ships required to fix it. Even worse, in the dark of the deep ocean, sovereign powers have started cutting the wires. This is the architecture of the abyss. Building the backbone of human civilization is not an open market. It is an extreme vertically integrated oligopoly. Only 4 primary corporations possess the capital and expertise to manufacture the fiber, armor the cable, and lay it across the ocean. The American Subcom, the French Alcatel Submarine Networks, the Japanese NEC, and China's HMN Tech. A select few others, like Italy's Prysmian, hold critical market shares. You simply cannot throw delivery trucks at this logistical problem. These entities own bespoke factories, the deep water piers, and most crucially, the highly specialized maritime fleets required to deploy the networks. The anatomy of these data pipes represents a masterpiece of material science compressed into a diameter barely thicker than a garden hose. The core consists of dozens of optical glass strands, each thinner than a human hair, carrying information encoded in pure light. Because photons inevitably degrade over vast distances, the cable is punctured roughly every 50 kilometers by repeaters. These 200 kilogram torpedo-shaped pressure tubes house erbium-doped fiber lasers. These act as underwater amplifiers, catching the dying light and forcefully launching it towards the next continent. To place this delicate technology on the seafloor requires a vessel that functions as a floating dynamic positioning factory. Consider Prysmian's Leonardo da Vinci. At 171 meters long, it is a maritime Leviathan equipped with DP3 dynamic positioning. Deep inside its hull sit 2 rotating carousels, acting like the gears of a gigantic watch, capable of holding a combined 17,000 tons of cable. As the ship pushes through oceanic storms, GPS and lateral thruster maintains its position down to the millimeter, while massive linear machines and a 100-ton capstan pay out the cable into the abyss. In shallow continental shelves, simply dropping the cable is insufficient. It must be deeply buried to survive dragging ship anchors and commercial fishing nets. This requires the Elodie, a 32-ton steel plow towed directly behind the vessel, dragging a trench of 2 meters deep into the seabed. When the delicate micro-adjustments are required, the crew deploys Hector 6, a 9-ton remote-operated vehicle featuring caterpillar tracks, 225 kilowatts of hydraulic power, and robotic arms that manipulate the infrastructure in total darkness. Despite the armor, the 32-ton plows, and the engineering brilliance, this backbone is staggeringly fragile. Geography mercilessly forces these cables through precarious global checkpoints. Nowhere is this more risky than the land bridge of Egypt. Nearly all telecommunications between Europe and Asia run through the Mediterranean, cross the mainland via terrestrial trenches to avoid the physical hazards of the Suez Canal, and re-enter the water in the Red Sea. 14 individual cable routes condense onto the single geographical bottleneck, handling roughly 17% of the world's intercontinental traffic. It is the ultimate single point of failure. In March 2024, suspected sabotage in the Red Sea severed 4 cables simultaneously, instantly vaporizing 25% of the data traffic between Europe and Asia. Accidental anchor drags account for the majority of faults, However, distinguishing between incompetence and malice is becoming increasingly difficult. A new era of grey zone maritime warfare has arrived. In November 2024, a Chinese vessel named Yipeng 3 severed two cables in the Baltic Sea by dragging its anchor for an astounding 180 nautical miles over the course of a day and a half. Dragging a massive steel anchor across the ocean floor for 180 miles is either the worst display of seamanship in human history or something else entirely. Shortly after, in early 2025, another vessel, the Hongtai 58, severed the TPKM-3 cable connecting the Fenggu Islands to mainland Taiwan. The captain was later imprisoned for international undersea cable damage. While dragging anchors offer plausible deniability, the technology designed for explicit disruption is evolving rapidly. In 2025 and 2026, details emerged regarding a highly advanced 30-meter disc-shaped underwater vehicle developed by Chinese science institutions. This is not a research probe. It is a deep-sea cable cutter. Operating at extreme depths of 4,000 meters, it utilizes an electro-hydrostatic actuator and a 150mm diamond-impregnated saw blade spinning at 1600 revolutions per minute. The sheer crushing pressure at these depths was once considered nature's ultimate security system. That defense has now been definitively breached. When a cut occurs, one does not simply call a plumber. Repairing the ocean floor is a brutally analog, time-consuming process. Dedicated maintenance vessels such as US-flagged CS Dependable and CS Decisive, each one 40 meters of dynamic positioning steel, must be rapidly mobilized. Crews drop grappling hooks into the abyss to blindly fish for broken ends, hoist them to the surface, manually splice in fresh fiber under microscopes, and meticulously lower the repaired segment back down. Each fault costs upwards of $1 million to fix, and severe weather can halt operations entirely. In one extreme case, an obscure deep-sea fault required an agonizing 947 days to fully resolve, and the demand for these repairs is colliding with an unprecedented maritime bottleneck. Industry projections forecast $13 billion in new cable investments by 2027, but capital cannot instantly rewrite physics. There are only about 50 to 65 cable-laying vessels on the entire planet, and building a single new ship requires 3 to 4 years and over $300 million. Compounding this crisis, the explosive growth of the offshore wind industry is aggressively competing for this exact same specialized fleet to lay high-voltage power lines. Tech giants and energy companies are now locked in bidding war for maritime steel. In volatile regions like the Baltic Sea, where operational risk surcharges have spiked 900% following the recent sabotage, day rates for advanced vessels have shattered €350,000 mark. The world is rapidly approaching a paradigm where there is abundance of gigabits, but a total absence of ships to carry them. To circumvent these bottlenecks and feed the insatiable data demands of AI, hyperscalers like Meta and Google are no longer renting bandwidth. They are simply financing their own infrastructure. Consider Meta's Project Waterworth. This single monopolistic initiative is designed to lay 50,000-kilometer cable system longer than the circumference of the Earth, navigating around geopolitical threat zones and plunging to depths of 7,000 meters. Utilizing 24 fiber pairs, it represents an unprecedented leap in capacity. The internet is physically re-architectured not by governments, but by AI models demanding unfettered access to global data. Faced with deliberate sabotage and critical shortage of human crews, the industry is turning towards intelligent autonomy. The manual monitoring of thousands of miles of seabed is being offloaded to machines. Systems like Smarty 200, an autonomous underwater vehicle developed by the University of Southampton, utilize advanced machine learning, SpiritNav mini navigation, and laser-guided computer vision, weighing a mere 70 kilograms and capable of executing complex zigzag search patterns over map uncertainties. These drones can detect, track, and inspect cables entirely on their own. They represent the first line of defense in an increasingly hostile, unpoliced underwater domain. The ultimate realization regarding the modern internet is that it remains stubbornly, inevitably bound by the physical world. It is not an ethereal cloud hovering benevolently above us. It is a physical, heavy, vulnerable entity strung along the crushing depths of the seabed in steel-armored tubes installed by quiet oligopoly and maintained by a handful of aging ships. Every financial trade, every global broadcast, every message sent across an ocean rides upon these dark hidden wires. Cut one and continents stagger. To understand the internet is to look past the sky and peer directly into the abyss. The true foundation of the digital age relies upon wires beneath the waves.